So we're talking about the substitution now. Not really, it's called the introduction of parameter. And it states that, let's say you have a general first order differential equation expression in these terms. And let's say that you cannot really solve for y prime. You cannot solve for y prime is equals to a function of xy. But in this case, you can solve for y is equals to a function of x and y prime. So we introduce a new parameter called p, and we simply set p is equals to y prime. So that means that dy over dx equals to p, and that means that dy is equals to p dx. Additionally, we stated that we could basically solve for y as a function of x and y prime. So it is also equals to a function of x and p, because y prime is equals to p. So then we can use the definition of a differential of a two-variable function or multivariable function. So it's the partial of x with respect to the first variable, which is dx, plus the partial of that with respect to the other variable, which is p. Right, and it is also equals to p dx. So we set this equals to 0, so we subtract that, and we get df over dx minus p dx plus df dp dp is equals to 0. And this, we obtain a symmetric first order differential equation. Let's say we find a solution p, which is a function of x, and c, which is a parameter in this case, or it's like a constant. So in this case, we get this relation, and we plug this relation into the original function that we solved for. We solved for y as a function of f of x and p, so we substitute in p for its function. So y will be equals to f of xp will be equals to f of x p of xc, which is just a function of x, right? Because the only independent variable in this case is x, and also c, but c is usually a constant, it's not varying, and this is usually just a constant value determined by the initial values. And yeah, that's it. So basically, you find this relation using this symmetric first order differential equation, and we substitute it in for this. That's what the introduction of a parameter method is.